you, hopefully. Oh, no, we don't want this. Sorry, wrong one. Let me just open up the correct one. Okay, so like I said, hopefully you have it in front of you, and then we can start with the marking. Come now. Okay, so how it's gonna work is I'm gonna go from top to bottom, and then if you can just give me the answers. So we're gonna start with Franco from the top, then work ourselves down. On the Discord you can see that left hand side, you can just run through it. Okay. Alright, so we have the binary to decimal, where we had to convert binary numbers to decimals. Okay, so I think Franco, you can start with us, and people, if someone gives an answer and you are not sure, then please ask me, then we can try and figure it out where you went wrong, and it would basically be just good practice to repeat a few of them again. Okay, but Franco, you can start for us. Franco? Okay, we can go to JP maybe?
So the first one is 16.
16?
Yes, sir.
Did everyone else get 16?
No, sir.
What did you get?
I got 166.
Yeah, me too, sir.
Okay, I also got 166. Okay, so JP, do you know where you went wrong, or must I explain? Okay, I'm just gonna continue, and then we can maybe at the end do just a few. Okay, so next up, Keegan.
I got 102, sir.
102, perfect. Okay, next.
So I got 63.
63, perfect. Next.
Yeah, I got 6.
6, awesome. Okay, now decimal to binary. JP, did you get the rest of these correct? Okay, no answer. Okay, so decimal to binary. Okay, so next up.
So I got 1101.
1101.
01. Yes.
Okay, anyone else? Is he correct?
I got.
I got 10101, sir.
Ish,
I got
okay.
one.
I got 11001.
Yes, I also got 11001. Okay, is anyone agreeing with me? Anyone against me? Okay, so I'll just explain that one as well. Okay, so let's maybe just explain. Okay, let's quickly look at the second one. Who was next?
Sir. Sir, I got 1000100.
Okay, almost. Can someone help him correct?
So I got 100001000.
Okay, I also got 3 O's at the back. Okay, is there anyone else that got it wrong? Okay, I'll try to explain that one maybe, perhaps, if we have time. Okay, the next one. Number 3, who's next in the queue?
So I got 1100101, so.
1100101.
Yes, sir.
Okay, that's perfect. Next up. Oh, JP, your mic's not working.
So can you hear me now?
Yes, there we go.
Okay, I'll do it. It's 52, sir.
Okay, that is the
Oh,
octal
no,
to decimal.
one,
That's
one.
yeah.
Yeah, mine is 1. Oh, mine is 1 1 0 0 0 1 1.
Perfect. Okay, the next one. Octal to binary.
52, sir.
52. That's correct. Next one.
30 sir.
30. That's correct. Next one.
So I got
172.
172.
172. Perfect. Next one.
I got 501.
501. 501. That's perfect. Okay, decimal to octal. Who's next?
So I got 415.
415 is good. Next.
214, sir.
214. Perfect. Next up. Next up.
So I'll go, it's 515.
500. 505.
15.
Oh, 15. Okay, cool. Yes, that's correct. Okay, next one.
145.
145. Perfect. Okay, let's go to the hexadecimal to decimal. Next.
I got 444 sir.
444. That's perfect. Next up.
So I got 142.
142. Is that correct?
Sir, I got 242.
Anyone else for 242?
Yes,
Yes,
sir.
sir.
I also got 242.
242. Okay. Next.
I got 170.
170. That's perfect. Next.
I got 1868.
Okay, 1868. Okay, almost. I got 2868.
Yes sir.
Yeah, me too, sir.
Okay, so
Me
286.
too.
Okay, do you see where you went wrong, or must I explain this one as well?
It's fine. Sir.
I'll just maybe add it in for the fun. Alright, let's go to the next one. Decimal to hexadecimal. And next up.
So
Sorry, is it my internet that's lagging?
So I think
Oh.
it's 6 and
Yes,
Right.
the storm. Okay, I think we'll skip you and then just the next guy in line.
So I'll go, it's 3B8.
That's perfect. 3B8. Next up.
16, sir.
16. Perfect. Next up.
95.
95. That's perfect. Next.
So I got 51.
51. Did everyone else get 51?
I got
No.
57.
No, sir. Got 57.
57. Okay. Wonderful. I also got it. Okay. Next we have octal to binary. No, hexadecimal to binary. Okay, remember this one I told you to first go to decimal and then to binary. So let's go carry on, but only give me the last answer, the binary answer.
So I got confused with this one as well.
Okay, next.
So it's
Uh,
0, Oh, sorry.
Nee, kom op, bro.
Okay, it's 000111010.
Anyone else?
So I got 11010.
I also got
Same.
11010. That's perfect. Okay, so I'm just gonna explain this one as well. Okay, next one. Hexadecimal, the number 2.
I got,
So.
oh, sorry.
Okay, one of you can give it.
I got 11001.
That's perfect. Okay, octal to binary, next.
So I didn't understand. Like, the opposite to binary, so.
Didn't understand.
So I got 110101.
11. Sorry, 1101.
1101. Sorry, sir. 110101.
Okay, I got something else.
Me too, sir.
I got
Me too, sir.
111101.
Same, sir.
So 111101.
Yes, sir.
Yes, sir.
Okay. Okay,
Yes,
next
sir.
up. Who's next?
I'll go, sir.
Yes.
110010.
That's perfect. 110010. Okay, next one. Binary to hexadecimal.
85, sir.
25. Perfect. Okay, almost there. Can we go to number 2?
$36, sir.
36. Okay, cool. Welcome, Bell. So we're just marking the homework now, the number system. So you can maybe just follow along if you want to. Okay, you said 36. That's perfect. Okay, octal to hexadecimal.
I got 3, sir.
3.
Yes, sir.
Anyone else?
Oh, wait. I got 30, sorry.
30. That's more like
Zero.
it. 30. Okay, people, the rest of you are very, very quiet. So either you got it wrong or you didn't do it. Okay.
So after hexadecimal, I was lost.
Same,
Okay.
sir.
Octal to hexadecimal, but tricky. Okay, I'll explain this one as well. Okay, okay, the 25 in octal to hexadecimal. Anyone? Answer? Anyone?
Can I answer, sir?
Yes, go for it.
15.
15. Okay, perfect. Okay, binary to octal. First one,
15, sir.
15. There we go. Okay, next,
27.
27. Okay, so people, can I quickly just take a quick survey? Why is everyone, why did you guys got very quiet? Is it this
It's
last
just-
part? Is it a bit tricky, this going from one number system to the other?
Yes, sir.
My methods weren't working out.
Okay, so what I think I'm gonna do, okay, I'm gonna take some time and explain. Okay, so I'm gonna open up my trusty Paint. This is gonna look absolutely terrible, but it's the best we're gonna do now. I forgot my writing pad at work. Right. Okay, so let's take a look at the first one. Let me just get a calculator over here. Okay, the first one, we had so 101001110. Okay, we had to take it from binary to a decimal. Okay, so if you have any number system going to a decimal, we know we are gonna be, first step we have to do is we're gonna just, for each and every single digit over here at the top, we're gonna go and write a base of 2 down. Okay, until every digit has a 2. Then what we're gonna do is we're gonna go to the right hand side, start at 0, and give each 2 an exponent. So 1, 2, 0, 1, 2, 3, 4, 5, 6, and lastly 7. Okay, then you're gonna just simply work out the exponents. So 2 to the power of 0 is 1, 2 to the power of 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, 2 to the power of 6 is 64. Yeah, this is terrible handwriting. It's funny, my own looks almost exactly the same. And then 2 to the power of 7 is 128. 128. Okay, so next step what we do is we're going to take, for every single digit over here, we are going to be multiplying it by its own number. So the first one is going to be 1 times 128 equals to how much? 128.
128.
Then we look at the next one. 0 times 64 equals 0, so I'm not
Zero.
even gonna write it. 1 times which one? 34 is
34.
34. 0 times 6 is, did I mess up somewhere?
Yes, sir. Isn't it supposed to be 32?
Yeah, it's 32. Okay, I think something I wrote there, something I don't even know what I said and what I wrote down there. It's supposed to be a 16 and a 32. There we go. Okay, sorry, does that look better?
Yes, sir.
Okay,
So-
the next one is 0 times 16 is 0, I'm not going to show that. 0 times 8 is 0, I'm not going to show that. 1 times 4 is 4. 1 times 2 is 2. 0 times 1 is 0. Okay, so that is going to be my answer if I calculate it. So 128 plus 32 equates to,
166.
okay, is that's all together, right?
Yes.
Okay, so 166. Okay, 166. Okay, do you guys understand how I got that 166?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, people, this is very, very, very important. Very important. Okay, so this is binary to decimal. Okay, ooh, is everyone dropping now? Like flies. You know, we still have a few. Okay, the next one I'm gonna quickly explain is this decimal going back to a binary. So I'm gonna do the 25 one. Just to recap your brain. So 25, that is in decimal format, I want to take over to binary. Okay, so if we take a look at what we must take over, it's gonna be 25. Alright, so then we start again by going to what do we need to convert to. So it's the base of 2. So I'm gonna start and I'm gonna say, okay, let's go 2 to the power of 0 equals to 1. Is 1 greater than 25? No.
No.
Then I carry on. 2 to the power of 1 is 2. Is 2 greater than 25?
No.
Then I carry on.
Also.
2 to the power of 2 is 4. Is 4 greater than 25?
No, sir.
No,
Carry on.
sir.
2 to the power of 3 is 8. Is 8 greater than 25?
No, sir.
2 to the power of 4 is 16. Is 16 greater than 25?
No, sir.
Then we get 2 to the power of 5, which is 32. Is 32 greater than 25?
Yes, sir.
Yes,
So
sir.
we're not going to use this one. So we're going to go to the most highest one, which is the 16. And we ask ourselves, how many times can 16 go into 25?
Once.
Once.
Once. Okay, then on the side we write 25 minus, we can divide 16 once into it, so it's going to be minus 1 times 16. So that's 25 minus 16, and that should give us
9, sir.
9. Okay, then we go to the next one and ask ourselves, okay, next one is 9. How many times can 8 go into 9?
Once.
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 Okay, so then I have my 9, and then I subtract the 1 8 that I could take out. Then I'm stuck with 9 minus 8 is 1. How many times can 4 go into 1?
0 times.
It can't, so it's 0. How many times can 2 go into 1?
Can't.
Again,
Zero.
can't, 0. Then we have the last one. How many times can 1 go into 1?
Once.
Once. And then we ask ourselves, okay, so what is 1 minus 1 times 1? Equals
0.
0. So if we reach 0, we filled all the columns with 1 digit, we know we are done. So that will be my answer. 1 1 0 0 1. Okay, do you guys understand?
Yes, sir.
Yes, sir.
So,
Is everyone on track?
Yes, sir.
yes, sir.
Okay.
Yes, sir.
Okay, Quentin, good.
Yes, sir.
Okay, just check your mic maybe there. Miguel, you good?
Yes, sir.
Okay, fantastic, people. Okay, so that is the first two. So octal to decimal, is there any queries?
No, sir.
Sir.
Are you guys sure?
Yes, sir.
Yes, sir.
Okay, then I'm gonna go to the next one. The next one is decimal to octal. Any questions?
Sir.
No, sir.
Any number I need to redo? Going once,
No, sir.
going twice, people don't be shy. And that's gonna be a no. Okay, hopefully everyone's good with decimal to octal. Hexadecimal to decimal, any questions?
Can you
Yes,
do
sir.
it
Put that number to word.
To the, sorry, the number?
number 2?
Number 2. Okay, so F2. How did we get that answer? Okay, let me just make a new page here. Okay, so hexadecimal to decimal. So I've got the number F2 and I need to take it over to, okay, that's to the base of 16. Sorry people, the handwriting is absolutely bad, I know. Maybe if I can just make this thing a bit thicker, that would also be good. Okay, F2 and I need to take it over to a decimal number. Okay, so firstly, what do? If I need to take something over to a decimal, anything over to a decimal, I'm not going to use the divide method. I'm going to go and see how many digits do I have. I've got 1 digit, I've got 2 digits. Okay, then I'm going to go and give a base for each of those digits. So I'm going to have a base 16 because I'm working with 16 over here. Then I'm going to go for the F, give that also the base of 16. Then we start at the lowest number, which is 0, and we give it to the first 16. And then we give the next one, which is 1. So it's 16 to the power of 0, 16 to the power of 1. Then I go back to the right hand side again and say, okay, what is 16 to the power of 0? It's 1. What is 16 to the power of 1? It's 16.
16.
Then you go and say, okay, cool. Let's quickly check what is F's value in the alphabet.
It's 15, sir.
Yes, because it's 1 up until 9. And then we get A, which is 10. B, which is 11. C, which is 12. D, which is 13. E, which is 14. And then the last one of hexadecimal is, sorry, that's a 0. I don't know why I wrote 9. Then we have F, which is going to be our number 15. So if we have 15, which is actually F, what is 15 times 16?
240.
240. Okay, then we add the next one. What is 2 times 1?
2.
2.
2.
So if I add this all together, I should get an answer of 242. And then I know I'm done.
So I have a question.
Yes.
It's about like when you convert to decimal to hexadecimal or decimal to octal, because I use 2 different methods. In the test, do you get like marks for the method that you use?
No, so what a few of my own students did is they used another method that they saw either in the book or on the internet. That's fine. What I do is if you got the right answer, then I mark everything correct, obviously. If you do not, but you must show how you got there. So don't just write an answer down, because then I have to penalize you, because the whole point of this is to see how did you get there, did you understand how to convert it. So even if you use another method and not my own, I will still mark it correct. So even if it counts 5 and you have 4 lines, I will still give you the 5 marks if you get the correct answer.
Alright, thank you, sir.
Okay. Okay, are we good with the hexadecimal to decimal? Any
Yes.
other questions?
Yes, sir.
No, sir.
Nothing. Okay, let's quickly go to decimal to hexadecimal. Are we good with decimal to hexa? Or do I need to quickly show one?
I'm okay with it, sir.
Can you please show one, sir?
Okay, which one? Can I show the last one? I think a few
Yes,
got
sir.
that one wrong. Is that good?
Yes, sir.
Yes, sir.
Okay, so let's start with 87. Okay, that is a decimal. Decimal, if it's decimal, we know we're going to use the division method. Okay, so then we have to take it all the way over to a hexadecimal. Okay, so if you have 87, I'm just going to rewrite my number down again, 87. So I'm going to go and write down the bases of 16 to the power of 0, and that will equal to 1. Then I ask myself, is 1 greater than 87?
No, sir.
Nope. Then I go on and say 16 to the power of 1 is 16. Is 16 greater than 87?
Sir.
Then I carry on. 16 to the power of 2 is equal to 256. Is 256 greater than 87?
Yes, sir.
So we
Yes,
are
sir.
not going to use this one. We're going to use the biggest one, which is 16. Then you ask yourself, okay, cool. How many times can 87 go into... Oh, sorry. How many times can 16 go into 87? So if you take a calculator, 87 divided by 16 will equal to...
Yeah, wait, sir. 5. It can go in 5 times.
So the actual answer on your calculator is 5,4, but it can only go into it 5 times without a rest or a remainder. Okay. Then on the side here, you're going to take your number 87 and say, okay, well, minus, how many 16s could I get out of this number? 5. So that would be 87 minus 5 times 16.
Which is
Okay.
8,
Will the answer be 8?
80. Oh,
Okay, okay, yes. The answer of 5 times 16 is 80.
Yes.
Okay. So what will be left here is going to be 7. That's correct. Then you
Yeah.
go on to the next one and you ask how many ones can you take out of 7?
7.
7. Okay. So what is 7 minus 1 times 7? Would be
0.
equals to 0. So you know that is going to be your answer. So you can write your 57 in hexadecimal. Okay, are we all good?
Yes, sir.
Yes, sir.
Any questions? Must I do another one as well?
No, sir.
No,
No, sir.
Are we sure?
Yes, sir.
I
Yes, sir.
Yes, sir.
Fantastic. Bell, all good?
Yes, sir.
Okay, people, then we're going to carry on to hexadecimal to binary. Okay, so here a lot of you said, ish, something went wrong somewhere. So I'm just going to explain the first one straight up. Okay, so if we have something like 1A that is in hexadecimal format, and we need to convert it to binary. The first step, what I said is, I'm just going to create an extra step here, is firstly I didn't teach you a way to go from hexadecimal to binary. That's not what I showed you. I showed you a way from how to get hexadecimal to a decimal, and also how to get a decimal to binary. So we're going to use that basically as a stepping stone. So firstly I'm going to take my hexadecimal, convert it into a normal decimal, then take my normal decimal and convert it into a binary. So I added just one more step for me. Okay, so if we take a look at 1a, if I need to convert something back to decimal, I'm gonna use the first one. So I'm gonna, or the first form, I call it formula or whatever, the method. So if you need to convert something to decimal, I'm gonna go and give each one of these a number. So I'm gonna go and say, okay, I've got 1, 2 over here. So what you can also do is, you can, maybe to make it easier for yourself, is start counting at 0. Just so, okay, so this is 0, 1. So I'm gonna give each one a base of 16. Then I'm gonna start at 0 and give the 16 an exponent, 0 and 1. So 16 to the power of 0 is 1, 16 to the power of 1 is 16. Now I can do my multiplication. There we go. Okay, 1 times 16 will equal to?
16.
15,
Okay, A is equal to what again?
10,
10.
10. So what is 10 times 1?
10.
10.
So 16 plus 10 will equal to 26. So that is in my decimal format, 26. Now I need to go and convert my decimal format into a binary, because I'm not done yet. So what I can do is I can just rewrite my decimal. If I need to go from any decimal to any number system, I'm going to use the divide method. The divide method is, I'm going to see, okay, I need to go to the power to the base of 2. So I'm going to start with 2 to the power of 0. That is 1. Is 1 greater than 26? No, then I carry on. 2 to the power of 1 is 2. Is 2 greater than 26?
No, sir.
2 to the power of 2 is 4. Is 4 greater than 26?
No, sir.
No, sir.
2 to the power of 3 is 8. Is 8 greater than 26?
No, sir.
No, sir.
2 to the power of 4 is 16. Is 16 greater than 26?
No, sir.
No, sir.
2 to the power of 5 is 32. Is 32 greater than 26?
Yes, sir.
Yes, sir.
So I'm gonna
Done.
leave this one out. I'm gonna go to the highest one, maybe draw some nice columns, and I'm gonna ask myself, how many times can 16 go into 26?
Once.
Once. So I'm gonna take 26 and I'm gonna subtract this one time. So minus 1 times 16. So 1 times 16 is 16. So 26 minus 16 is
10.
1.
10,
Which is-
hopefully.
It's
How
gonna
many
say
8s can you take out of 10?
1.
1, sir.
1. So what is 10 minus 1 times 8? So 1 times 8 is 8. So what is 10 minus 8 is?
2.
How
2.
many 4s can you take out of 2?
0.
None, sir.
How many 2's can you take out of 2?
1.
So
One.
what is 2 minus 1 times 2?
0.
Oh, sorry.
2 minus 2 is hopefully 0. And how many 1's can you take out of 0?
0.
0. So your answer will be 1 1 0 1 0. And then obviously in binary format, that is not a 3, that's a 2 over there. Okay, all good.
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay, I need a confirmation from everyone. So let's go down the list. Bal, good.
Yes, sir.
Franco, good.
Yes, sir.
JP, good.
Yes, sir.
Keegan, good.
Yes, sir.
Keshan,
Yes, sir.
Miguel,
Yes, sir.
Mpo,
Yes, sir.
Quentin. I'll take that as a yes, sir. Okay, people, don't you dare get this wrong tomorrow. I'm kidding. I'm kidding. It's fine. What's next? Okay, octal to binary. All good, or must I do one just to show again?
Can you do one, please,
So-
sir?
Yeah.
Okay, so it's going to be basically the same format for everything, but I'm going to do one and then we can see from there on. So 75 octal. What must I do to get it to a binary?
Let's put octal to a decimal.
First I'm going to take it to a decimal, and then from decimal I can take it to a binary. Okay, that's a bit dramatic. Okay, so if I want to take any number system to a decimal, I'm going to go and mark my numbers here at the top. So I've got 0, I've got 1. Then I'm going to give for each of these digits a base of 8, because I'm working with 8 over here. So I'm going to say 8, 8. And then I'm going to start with my 0, and I'm giving the base numbers exponents. So 8 to the power of 0, 8 to the power of 1. This will equal to 1. 8 to the power of 1 is 8. Okay, then you simply multiply. So 7 times 8 is equal to
56.
56. Okay, 5 times 1 is equal to
5.
5. So 56 plus 5. Is that correct?
Yes.
Okay, so that will equal to
61.
61. So that is in decimal format. Is 61. Now I need to take my decimal over to the binary. So I'm just going to rewrite my 61 again. Okay, if you want to take a decimal to anything else, it's going to be the division method. So I'm going to go and say 2 to the power, oh, I'm going to need more space. Okay, I'm going to go and say 2 to the power of 0 is equal to 1. Is 1 greater than 61?
No.
2 to the power of 1 is 2. Is 2 greater than 61?
No.
2 to the power of 2 is 4. Is 4 greater than 61? 2 to the
No.
power of, what's this, 3 is equal to 8. Is 8 greater than 61?
No, sir.
2 to the power of 4 is 16. Is 16 greater than 61? No.
No.
2 to the power of 5 is 32. Is 32 greater than 61?
No, sir.
2 to the power of 6 is equal to 64. Is 64 greater than 61?
Yes, sir.
No, sir.
Yes, so we're gonna scratch
Oh,
that
sorry,
one off.
sir, sorry, sir.
Then we're gonna go to 32, and we're gonna ask ourselves, maybe draw some neat little nice columns. Is sorry, how many times can you take out 32 out of 61?
Once.
Once.
Once. Then you go and write 61, shucks, 61 minus 1 times 32 is
It's
equal to,
29.
it's
Yeah,
equal
the-
to 29, that's correct. Okay, how many 16s can you take out of 29?
1.
Okay, then you say 29 minus 1 times 16,
It's 13.
that's 13, that's correct. Okay, how many 8s can you take out of 13?
1.
One, sir.
1. What is 13 minus 1 times 8? 5.
5.
How many 4s can you take out of 5?
1.
1, sir.
1. So what is 5 minus 4?
1.
How many 2s can you take out of 1?
None.
How many
None,
1s can you take out of 1?
sir. 1.
So 1 minus 1 times 1 equals?
0.
Okay, so you've reached 0 here, and each column has a digit in, and then I know that is going to be my answer. So 1 1 1 1 0 1. Okay, someone who answered me said it's, I think, 1 1 0 1 or something. Did you fix it now, or do you see where you went wrong? Okay, is everyone good with this one?
Yes, sir.
Can you
Yes, sir.
see? It's simply
Yes,
just going
sir.
to decimal and jumping from decimal over. Okay, but let's take another one. I'm gonna quickly do this. No, I don't want to go that route. Okay, yeah, let me go that route. Let me explain this octal to hexadecimal for those of you that got it wrong as well. Okay, let's take a look at the 61 first. Okay, so 60 in octal, and we need to take it to hexadecimal, but I know I need to have a middle step, so I'm going to include my decimal over here, and then I'm going to take it over to hexadecimal. Okay, if I need to convert anything into a decimal, I'm going to go and give it the numbers at the top. So that's my 0, that's my 1. Then I'm going to give for each one a base of 8. So 8 to the power of 0 and 8 to the power of 1. 8 to the power of 0 is 1, 8 to the power of 1 is 8. So then I can say, take my first digit, multiply it with the first answer I got. So 6 times 8 equals to 48, that's correct. Plus my, what is 0 times 1?
0.
So my answer would be 48 in decimal. So 48. Okay, now I need to convert my decimal over to a hexadecimal. So I'm going to write my 48. Then because I need to convert decimal to any other number system, I'm going to use the division method. So I'm going to give start with my base. 16 to the power of 0 is 1. Is 1 greater than 48? No. 16 to the power of 1 is 16. Is 16 greater than 48?
No.
16 to the power of 2 is 256. Is 256 greater than 48?
Yes.
So we leave that one out. So we only have these two. Then we ask ourselves, how many times can 16 go into 48?
3 times.
3 times. Okay, 3 times. Okay, so what is 48 minus 3 times 16?
That's 48. Wait, I think.
That's correct, it's 48. So what is left over?
Oh, sorry. Yeah, I just froze for a second. 0 is left over.
Okay, why is one person answering me? Is everyone good?
Yes, sir.
Yes, sir.
Are you sure?
Yes, sir.
Yes, sir.
Okay, so 0 is left over. Then you ask yourself, how many times can 1 go into 0?
0 times.
None.
0. So your answer is 3 0 30. Okay, are we all good?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
You understand number systems completely?
Yes, sir.
Yes.
Okay, fantastic. Okay, so then I'm just going to do one more thing, and I'm going to quickly go through one trace table. Okay, so I just want to open up another Excel document over here quickly, and then I'm going to be doing in your textbook, it is on, well, digital page 172, and it is on the paper, it's page 166. I'm gonna quickly just work through this algorithm. So don't stress, you will get the trace table, but I'm just gonna quickly explain how I'm gonna create the trace tables like the columns, and then I'm gonna work through this and actually see if I can complete this algorithm or this flowchart. Okay, so firstly we begin at the top, it's start. So let's see if I can identify all the variables and all the decisions that needs to be made, as well as the inputs and displays. Okay, so firstly, what is the first variable you see?
Inum.
I count.
So it's gonna be inum, because that get inum means get the number and store it into inum. So that's the first variable we see. The next variable we see is gonna be the iCount variable, because 1 is assigned to iCount. Okay, the next thing, what's the next thing we see happening in this flowchart?
Decision, sir.
We have a decision, so let's put the decision in there. So is iCount smaller or equal than inum? Okay, the next thing we have, or what we can see, is again there's another decision here, and it asks is inum mod iCount equals to 0. What does mod do again, people?
That
It gets
divides.
the just like you divide two numbers and then you get the remainder.
Yes, so it divides two integers and get the remainder. What does div do?
It divides the sum and it throws away the decimal.
Divides the sum, or divides two integers and throws away the decimal. Perfect. Okay, someone else that has not answered yet. What does trunc do? Anyone else?
It chops off the decimal and it gives an average.
Okay, it gives an integer. But yes, it chops off the decimal. If you think of a tree trunk that you have to cut off, and you're left with the trunk, that means cutting off the decimal. Okay, and then yes, you are left with an integer. Okay, and then the last one we have is someone else that I have not answered yet. What does two arrows or less than and greater than, if they are facing like the two mouths open together, what does that mean?
Not equal.
Sir, it means not equal to.
Okay, perfect. Thank you, everyone. Okay, so we've got mod, div, the not equal to sign, and the trunk. Please remember those. Okay, so this was the mod decision that we can see on screen. Nextly, we can see there's an instruction, add iCount to list of factors. So list of factors might be also a variable. So let's just call this factors. Okay, the next thing we see is, can everyone see? Is it big enough?
Yes.
I can see it, sir, but I'm not sure about the others.
I'll just zoom in once more. Alright. Okay, then we can see we've got iCount equals iCount plus 1, and that means basically increment. So we have already an iCount variable, so I'm not going to create one again. Then we go up to the loop here at the top. It says iCount less than, greater than. Okay, if we take the false path this time, display list of factors. Fantastic. So let's display. And then we can see we reach the end. So that is going to be my trace tables layout basically. So let's go through this this flowchart and let's try and see if we can get this thing to work. So let's at get inum add the number 6. Okay, so we entered 6 into inum. Then the next thing, it says iCount gets the value of 1. So we go over to iCount in the column and we add the 1 there. Then the next step is the decision. Is my iCount, so is 1 less than or equal to 6? Yes, it is. It's 1 is less than 6. So I'm going to take the true path. downwards. Then I get another decision, inum mod I count equals to 0. So my inum, what is my inum? It is 6. So if I take 6 divided by what is an I count, it's 1, I get a complete value. So 6 divided by 1 is 6, obviously, and there's no remainder. So that means there is a remainder of 0. So this statement is true. Is everyone still following?
Yes, sir.
Fantastic.
Yes.
It's true, so I'm going to go down with the flowchart. I'm going to take the true path. Note there's no false. Okay, the next one I have is add I count to the list of factors. Okay, so I count is what? I count is 1, so I'm going to add 1 here. Then I go on to the next one. I count equals I count plus 1. Okay, so I count is whatever I count was plus 1, so it's 1 and then it becomes 2 now. Then it goes all the way up to the next decision. Is my I count less than or equal to I num? 2 is less than 6, so it will be a true again. The next one, my I num mod my I count equals to 0. Okay, so is that true? Yes, it is true. If you say 6 divided by 2, you will not get a remainder. So that is true again. Next step, add I count to the list of factors. So let's separate 1, 2. Okay, so because factors is, there's already 1 stored in it, so I'm just adding the 2. So I'm just creating the comma just to separate the 1 and the 2 with each other. Okay, then we go on and see I count is equal to I count plus 1. So it was 2 plus 1, it becomes 3 now. Then it loops up to the top. I count is I count less than or equal to I num? Yes,
True.
it still is, so it's going to be true. Next one, is my I num, which is 6, mod my I count, which is 3 at the moment. If you mod them, will you get a remainder of 0? Yes, so that's true again. 3 is 6, it divides in it perfectly. Then we add I count to the list of factors. So the list of factors is 1, 2, and then I add the I count, which is 3. Next step, I count equals I count plus 1. So I count is now 4. Is my I count less than or equal to 6? So is 4 less than 6? It is, it's true. I'm going to take the path of the true. Then I think they slipped up here with this flowchart. There should have been an arrow for false heading or skipping, but what I'm assuming here is the first one will only be done if it's true. If it's not true, it's going to skip the first one and go to the second one. So that's what I'm kind of assuming. Normally the false path would have actually skipped just the add I count to list of factors block, but yeah, who am I to judge? So we have the question, is my I num mod I count equals to 0? So is 6 divided by 4 equals to like a whole number? No, it's not. It's 1, 5. So I know that is false because it has a remainder. So this one will be false. Then we actually, so this add I count should not actually be run this time. Then we go to the next one, is I count equals I count plus 1. So I'm going to go to my I count. It was 4, it now becomes 5. Then I ask again, is 5 less than 6?
True.
It's true. Is my I num, which is 6, mod 5 equals to 0?
False.
It's false. Okay, so again, my add I count to list of factors should not run. It should go straight to I count equals I count plus 1, which is equals to 6. Is 6 less than or equal to 6?
True.
Okay, listen nicely. Is 6 smaller than or equal to 6? So that or means it can either be less than or it can be equal. So it is equal, so I'm going to have my true written there. I've got a bit of OCD, that must also be capitals. There we go. Okay, so now we ask ourselves, is inum, which is 6, mod, so divide by 6, equals to 0? Is there a remainder? No, there's no remainder. The remainder is 0, so this is in fact true. So then that line add I count to the list of factors would actually execute. So my list of factors at the moment, if we look at the top, is 1, 2, 3, and now I need to add I count, so it's 6.
6.
Then we follow the next one is I count equals I count plus 1, which is 6 plus 1 is 7. It loops up to the top. Is my I count, is 7 less than or equal to 6?
False.
False.
False. Okay, so I'm going to go on. I'm going to follow the false path. And then it says display list of factors. So I'm going to go to the display column, and I'm going to display what is inside my list of factors. And at the moment it's 1, 2, 3, 6. And if I follow to the next one, it says end over there, and that means I am done. Okay, remember factors is what can divide into a number without the remainder. So if we take a look at this display, is that factually correct? If we take the number 6, what is the factors of 6? So 1, yes, 1, 2, 3, 4, 5, 6, it divides into it nicely without the remainder. If we take a look at 2, 2, 4, 6, it divides in it nicely without the remainder. If we take a look at the next number, 3, 6, divides into it without the remainder. And then if we take a look at the number 6, 6 goes into 6 without a remainder. And that is basically all we have to do for this flowchart. Is everyone with me?
Yes.
So it's easy. You just follow the instructions and just change it if it changes in the flowchart. Okay, all good.